Okay guys, so this is going to be our lesson over exponential increase and decrease example problems. So pretty much like what we did before with interest problems, the formula looks like this for increase and decrease. No, there's no n in there. It's just r and t like that. Now, if your rate is negative, it's going to be a decrease problem. If it's increasing, it's going to be positive. So you just kind of got to deal with it that way. Okay, so the population of Greensville is increasing at a rate of 5.6% per year. If the population today is 8,000, what will it be 10 years from now? So our initial amount is 8,000. It's increasing at a rate of 5.6%, so 0.056. Convert it to the percentage to a decimal, and our time is 10 years from now. Okay, so what I would do if I'm putting this in the calculator, I'm going to do 1.056. Okay, and I'm going to raise it to the 10th power. Okay, and then I'm going to multiply it by 8,000. Okay, so you get 13,795.237. Okay. If you have an investment account that is increasing at a rate of 2% per month, if you have 700 invested today, how much will you have 2 years from now? And then when will you have $10,000 in your account? Okay, so we're in months, so you have to make sure you pay attention to that. So A is equal to 700 is your principal amount. It increases at 2% per month. And I want to know 24 months from now. That's what 2 years is. Okay. So I just put that in the calculator. We get 1.02 to the 24th power. And I get 1.6084 times 700. Okay, so I have 1125.906. $91, sorry. Let's go 2 decimal places. And then it asks, when will you have $10,000? So I'm going to say $10,000 is my final amount. My initial amount, 700. This stays the same, 1.02. And I'm looking for how long it's going to take, okay? Remember, our time is in months. I'm going to go ahead and cancel 2 zeros, So we get 100 divided by 7 is equal to 1.02 to the t power. Okay, it's a simple exponential equation. We're going to natural log both sides. T natural log of 1.02. And then I'm going to divide. So t comes out to be, so we do natural log of 100 over 7 divided by natural log of 1.02 and 134.288. And that's in months. Okay. Now, if I want years, I just divide that by 12. And so it's 11.19 years. Okay. Suppose that you take an 800 milligram aspirin at 1 p.m. 5 hours later, you have 100 milligrams left in your bloodstream. What is the rate of decrease of the aspirin in your bloodstream? Okay. So our initial amount is 800. Final amount is 100. So we say 100 is equal to 800. 1 plus r. And 5 hours later, your time is 5. So what we're going to be doing is solving for r here. Now, your r, we're not going to make it negative right now. We'll make it negative whenever we get our final answer, okay? So we can cancel 2 zeros on both sides, 2 zeros on both sides. So this is 1/8 is equal to 1 plus r to the 5. Now, if I want to solve this, I can natural log both sides. So we get natural log of 1/8 is equal to 5 natural log of 1 plus r, like that. I'm going to divide the 5 over. And I get natural log of 1 plus r. I don't know if we've worked one like this. Now, to get rid of the natural log, we're going to e both sides. So we'll e both sides, e both sides. And I'm going to go ahead and put this in the calculator. So we get e to the natural log of 1/8, close parentheses, divided by 5, close parentheses again, and you get 0.65975. Is equal to 1 plus r, and then we can solve for r. And our r would end up coming out to be negative, so 0.65975 minus 1, and you get negative 0.34025. So if you're gonna talk about the rate of decrease, it comes out to be negative. And if you want to write it as a percentage, move your decimal place over 2%, 2 decimal places. Okay, so that's a little bit tricky one. You also could have taken this and found your zeros, and we're going to be looking for the negative one. So if I want to do it that way, 1 plus x to the 5th power minus 1/8. Okay, so I'm looking for decrease. So I'm over here somewhere. You know that a rate has to be in between 0 and 1 as a decimal. So let's change our window from -1 to 0. Okay, and it looks like it's going to cross over there. Calc. And I'm going to pay attention to my y value. It's still negative, still negative. So we'll go below and then change the sign, positive, positive. Okay, and we got the same answer. Okay, so those are 2 alternative methods to dealing with this problem. Okay, a virus grows at a rate of 2.8% every day. Currently, there are 20,800 deaths from the virus. How many deaths can you predict by the end of week 7? By the end of the week, 7 days, okay, is what we're gonna assume. And exponential growth. So we're going to say A is equal to 20,800. Your growth rate is 1 plus 0.028. And I want to know 7 days later. Okay. So 1 plus 0.028 to the 7th times 20,800. Okay, so by the end of the week, we're going to have 25,235.687 deaths. Okay, when I wrote this problem, I think I wrote it in either March 2020. Yeah, way back when we only had, X amount of deaths from Corona. And I just picked a number, what I thought what the death rate was from the data, and I was conservative in it, and I was really, really, really close to predicting how many people actually died by the end of the week because it was following a pretty good exponential model. Okay? Okay, next one. Bacteria can multiply at an alarming rate when each bacteria splits into 2 new cells, thus doubling. If I start with only 1 bacteria, which can double every hour, how many bacteria will we have by the end of the day? Okay. So A is equal to, I start with 1, and it doubles. So if something's going to double, that means you're multiplying by 2's. Okay. And I want to know how many bacteria will I have by the end of the day. It doubles every hour, so this is going to be 24. So 2 to the 24th power is that. 1677216. Okay, so if I have bacteria that split, okay, it's going to continue to grow. I mean, you get 16.7 million bacteria by the end of the day. That's a large number. Okay, the population of Winnemucca, Nevada, I just butchered that, is given by the function P of t is equal to 6191 times 1.04 to the t power, where t is the number of years since 1990. What was the population in 1990? So if we're looking at a model like this, the initial population is 1990, so 6191. So P of 0 is equal to 6191. Okay. By what percent did the population increase each year? Okay, so we're looking at our R. So to find our R, this is actually 1 plus R, correct? So your growth rate is 4%. Okay, and I put this question there because it asks these types of questions on SAT. They give you a question like this, and they ask you information like that. So, okay, your savings account is growing at a rate of 3.2% per month. How long will it take your account to triple in size? So we have our formula right here. Okay, so it's tripling in size. So 3P is equal to P times 1 plus R. Your growth rate is 0.032. Okay, so your P's will cancel on both sides. Okay, so we get 3 is equal to 1.032 to the t power. Okay, so to solve this, we're going to natural log both sides. So we get natural log of 3 is equal to t natural log of 1.032. Okay, and we're going to solve. And so we get 34.878. And we were in months, so let's stick with months. And the last example problem. You buy a new computer for $2,100. The computer decreases by 50% annually. When will the computer have a value of $600? Okay, so this is going to be depreciation. So your initial amount is $2,100. It's decreasing by 50% annually, so we're going to subtract 50%. And we're looking for when will it have that value, okay? So 1 minus 0.5 is 0.5. 2 zeros will cancel. So we get 6 over 21 is equal to 0.50 to the t power. And to solve this, we're going to natural log both sides. Okay, so we get t, we'll divide that over. So we get t and natural log over 621 divided by natural log of 0.50. Okay, so you get 1.807 years. Okay, and this makes sense because, okay, after 1 year, we're going to take half of 2,100. It's 1050, okay? So at the end of the second year, it'll be down to 525. So we should be somewhere in between 1 and 2. And that answer makes sense. Okay, so this has been exponential increase and decrease example problems. Hopefully you found this useful. So thanks and have a good day.